Good afternoon, everybody. Thank you so much for joining us today for this CISEC Masterclass. As you can see, this one is focusing on a history of identity management and a look to the future. Before we make a start with the introductions, I'm just going to use this bit of time to run you through our house rules. If you're a CISEC member and you've attended some of these events before, you'll already be quite familiar with the etiquette that we follow. But if you're not, then welcome. This masterclass is brought to you by the Chartered Institute of Information Security, or better known as CISEC. And here are our house rules. So just to let you know, you will be muted for the next hour, but please do type your questions through to us using the Q&A box, which should be at the bottom of your screen. And we'll be moderating those throughout. Please do type them through to us. If you really want to ask them anonymously, then you can as well, but this is very much a safe space. No question is a stupid question, and we hope to have some great discussion going on at the end. As it says there, if you do have any problems, which hopefully you don't, then please do let us know at support@cisec.org, or do say hello in the chat, or let us know there as well. But do try to keep the questions in the Q&A box, just makes things a little bit easier for us to control those at the end. As I said, this masterclass is on a history of identity management and a look to the future. And on the side, you should be able to see our panelists today. So the host for today's webinar is Kevin Streeter, who is one of our very own CISEC board members and a fellow of CISEC. This is right up Kevin's street, as he told me before, has so much experience in this area. And Kevin is currently the Vice President at ForgeRock, where he heads up the global customer education business. So I'm going to hand over to Kevin to get us started and to introduce our other guests.
Thank you very much, Sophie, and welcome everyone to this afternoon's masterclass, and very pleased to be with you all. And I'd like to introduce David Chadwick and Sean Arrowsmith from Crossword Cybersecurity. David is going to be our speaker this afternoon on the history of identity management and the look to the future. And just some background on David. David's been Professor of Information Security at the University of Kent and at the University of Salford. Well over 20 years experience in the identity and access management and authentication space, and is the BSI representative for the UK on the X500 standards. So a real expert in the field, and very much looking forward to David's view on what's been going on in the identity world over the years, and particularly where we're going in the future. So with that, I'd like to hand over to you, David, and I believe we've got a short introduction about Crossword Cybersecurity to begin with from yourself, Sean.
Yeah, correct.
Oh, just while I bring up the slides, to say there will be a Q&A time at the end, so please put your questions into the Q&A, and I'll be moderating the session with David at the end of the talk today. So over to you, Sean.
Thanks, Kevin. I'm going to be very quick, actually, because obviously we want to get on with the interesting part, which is David giving his presentation. Just wanted to give you the obligatory quick overview of Crossword in case you haven't heard of us. We listed on the AIM market, London Stock Exchange, at the end of 2019, so we've been established for a few years now, but we are a technology transfer company, and our work is often looking for innovative research and companies coming out of the university sector and higher education to create new cybersecurity and risk management software products. And actually, David was the CEO of a spin out from the University of Kent, producing a product in verifiable credentials called Identiproof, which is something that we'll touch on today. We're also offering people, if they want to sign up for a meeting at the end, there's a link that you can go and sign up for a meeting to have a look at that platform. We have a couple of other products, Risic Assurance, which looks at supply chain risk management, particularly from a cyber security perspective, and drives automation in supplier assurance. And actually, it's a member benefit for CSEC members. They can get access to a free version of that platform. And then Nixa is a product that looks at detecting credential stuffing attempts for on web applications using machine learning. We also, through a recent acquisition, have a managed security operations center and monitoring organization delivering what we call our Nightingale service. So that's another area that we are delivering services in. And we have a consulting team that focuses solely on cybersecurity, everything from maturity assessments through to policy, through to pen testing. So without any further ado, I'll pass over to David, and we can get into the interesting part of the presentation.
Thank you very much, Sean. So I'm going to talk to you about the evolution of identity management over the last 30, 40 years. A somewhat unbiased view. I'll try and make it as unbiased as possible. We're going to look, first of all, going back right down to 1988 when X509 was first published, and then look at how things have evolved from there, and finishing with the latest standard, which is W3C verifiable credentials. So here's a little joking thing about the history of identity management. 1980s, when I was working at the University of Salford, we did connection between computers, and I would send messages to people, and they said, "Who are you?" And I said, "I'm David." They said, "Yeah, sure you are. Why don't you add username David?" And that's all we did to identify ourselves. And then in the 1990s, some clever guy from CERN invented the World Wide Web. So they said, "Why don't you add a password?" So I said, "Yeah, what about 1, 2, 3, 4, 5, 6? Brilliant, that's fine, no problem." But then when the 2000s came, we became overloaded with passwords. I mean, I've got over 100 myself. So we said, why can't we federate systems together, and we can use one password for multiple services? And then SAML was born. And then in 2010, we said, well, there seem to be too many password hacks. Why don't we add on two-factor authentication? So now we have that, but it's a bit of a hassle, isn't it, having to get your mobile phone out and type a number in. And now, bringing it right up to date, here's the latest system. Please present the following verifiable credentials to prove your identity. The user simply selects the verifiable credential on his phone, touches the fingerprint reader to create a digital signature, and she's identified, authenticated, and granted access. So that's hopefully where we'll get to this decade. Here are the top 10 favorite passwords from last year. You can see that 1, 2, 3, 4, 5, 6 is still the #1 password. The one that we used right back in the 1990s is still there in the top 10. And here's a joke from the 1990s, which some of you might be familiar with. On the internet, nobody knows you're a dog or a fraudster, hacker, or anything else. And that's what we're trying to address with identity management. So back in 1988, we published X500, and X509 was the authentication part, which used public key cryptography and certificates. And it's been one of the most successful standards that there's been in terms of security, because now virtually every web server on the internet uses TLS, which is based on X509. So that's really good. What are the interesting features in X509? It uses ASN1, which is abstract syntax notation 1 for compact type length value encoding. It can support any existing future encryption algorithms, so it'll be future proof against quantum computing and things like that. It's got a version number, so it can evolve, and we're now on version 3. And in version 3, you can add any number of extensions to X509 certificates, which means that they can be adapted and used by any different group of users by adding their own extensions. And the extension can be flagged critical or not. So that if you don't understand an extension, you must refuse to accept the certificate if it's flagged as critical. But if it's not flagged as critical and you don't understand the extension, you can ignore it. And that same concept is now in OpenID Connect. But what are the negative features of X509? Well, encoding ASN1, so difficult for implementers, administrators, and users to use. Bad implementations abounded in the early days. Lack of good ASN1 tools meant no end users could really handle public key certificates. And another problem was it assumed everyone would have a certificate with a certification authority, and that was what's called the three-cornered trust model. It also lacked privacy protection because users' globally unique distinguished names were always released to everyone. So you've got a globally unique handle that you gave to everywhere you went on the internet, which is not good for privacy protection. And certificate revocation has proved to be a very hard problem to solve, so much so that there's a tendency now for CAs to be issuing shorter and shorter certificates, and browsers are stopping accessing certificate revocation lists. This is the three-cornered trust model that was originally formulated in 1988. As you can see, the relying party has a relationship with a certification authority and trusts it, but end users really don't know much about certification authorities, and they don't know who they can trust. So at the moment, that role is played by the browser, and the browser tells the user which certification authorities they can trust, and that's not really a good model. Now, back in the 1990s, there was a European research project called RACE, and that looked at strengthening Kerberos with public key cryptography using X509, but they also invented this concept called a privilege attribute certificate, which was for authorization to go with the authentication of X509. And that led to an internet draft and eventually to an ECMA standard in 1966. What are these attribute certificates? Well, basically, they actually allow you to assign attributes to an entity and to digitally sign it by the issuer. And this was taken by, it took the ECMA pack and it turned it into X509. And so we have the concept of an attribute authority, which is similar to a certification authority, only now an attribute authority is issuing attribute certificates. What are the interesting features about it? They're always digitally signed by the attribute authority, who's the issuer. The user can be identified by a name, an X509 public key certificate, or simply a public key. And the certificate contents are any set of attributes. So in fact, a public key certificate is actually a specialized attribute certificate. Not many people realize that, but it actually is. And it actually became the conceptual basis for SAML. And we'll look at SAML in a short period of time. What are the negative features of X509 attribute certificates? Well, the use of ASN1 made it hard to use. Lack of tools for ASN1, lack of tools for handling attribute certificates. So it didn't really get accepted in the world at large, although there are little isolated pockets of implementation of attribute certificates still today. Now, in 2016, the X509 standard introduced a four-cornered trust model because it recognized that users don't trust certification authorities, don't know anything about them. And the trust broker is introduced as an entity that a user has a relationship with, that he pays money to, and the trust broker will indemnify him and actually fund him for any financial losses that he might get from this environment. And this is described in a paper that we wrote in 2017 in the Security and Communications Network magazine. And it's now implemented. It's now part of the IDAS scheme, and it's called the Signature Validation Service. And the expectation is that users will have relationship with signature validation services, and they will validate public key certificates on behalf of the user, and they will take the liability, and they will pay money to the user if the user suffers loss. And there are currently 17 signature validation services operating throughout the EU, and you can find a list of them here. You'll get the slide, so you'll get the URL to copy and paste later. And probably not commercially viable at the moment, but it's only just starting. So back to the 1990s, people realized that X509 wasn't the solution to everything. And Ron Rivest, who is, as you know, the author of the RSA algorithm, which underpinned X509 in the early days and still does to some extent today, he invented the simple distributed security infrastructure, which was known as SUDSI. And the goal there was to build secure, scalable, distributed computing systems. And here's the difference: binding local names to public keys, no longer buying X509 distinguished names and global names, but local names to public keys. At about the same time, Carl Ellison invented the simple public key infrastructure, and that allowed binding authorizations to public keys. And the two guys got together and they formed SUDSI SPKI that was released in 1988. So that has some interesting concepts, which is that keys can be used for identification, authentication, and authorization without needing external authorities, because users are doing this themselves. They're issuing the certificates themselves. And the keys, as I said, the names are bound to keys. And later versions of X509 attribute certificates adopted that model and bound attributes directly to keys. And FIDO also, which is a much later standard, now uses raw keys for authentication with no need for external certification authorities. So those concepts have come through to the modern day. It also had the concept of threshold subjects, where you could grant access to a set of subjects where K of N of listed subjects would sign a request, and then the subject would be granted access if that threshold was released. And that's now being considered for adding to version 2 of the W3C verifiable credentials data model. And then in 2002 to now, SAML was invented because X509 proved to be unusable by most end users for reasons that I stated earlier. So it was an XML alternative to X509 public key and attribute certificates. 3 versions of SAML have been published. We're on version 2 still today. And it specified 3 types of assertions: authentication assertions to replace X509 public key certificates, attribute assertions to replace X509 attribute certificates, and authorization decision assertions, which actually became not used anymore and deprecated and replaced by XACML, which was another OASIS standard. So what are the positive features of SAML? It's used by web browsing HTTPS, protects all protocol messages, and it had excellent privacy protection. I really like the privacy protection from the original Shibboleth. And this was that user IDs remained private to the identity provider. It was never released. Users were given transient IDs, which changed every time they accessed a site. What this meant was that a website could not detect that it was the same user accessing it twice, or whether it was two different users, because they had different transient IDs. The only way you could identify a user was from their identity attributes. So if the user wanted to be re-identified, he'd make sure that identity attributes were the same each time. And as I said, this is really, really good privacy protection that guaranteed total privacy protection for the user if they wanted it, but they could release their identity attributes as they wanted. And they had attribute release policies for this as well. And the other interesting feature was it issued short-lived assertions and no revocations. The reason being X509 public key certificates proved difficult with revocations, and say still difficult today. So they decided we're not going to have revocations. We're going to issue short-lived assertions, then we don't need revocations. But what are the negative features of SAML and all the federated identity management protocols? Well, they're open to phishing attacks. And this is how a phishing attack works. A user is tricked to go into a website. The user doesn't know that the website is evil, but they contact the website redirects them to their SAML attribute authority to log in. It looks like their identity provider, but it's actually a fraudulent one because it's used the same language, it used the same page mockup, but it's just a URL that's somewhere different. But the user is tricked, they authenticate, they send their username and password, and they're phished. So that's a problem with the FIM systems and SAML and Shibboleth, and also with OpenID Connect to a certain extent. So what else? It provides maximum privileges rather than least privileges, because all the user's attributes are released at login time rather than when they access different resources. So that's not good for privacy protection. And another problem was they found that identity providers were not willing to release enough of the user's attributes because the trust model was that the IDP had to trust the service provider. And because they didn't necessarily trust the service provider, they weren't willing to release enough of the user's attributes for the user to get sufficient services from the service provider. And also it uses bearer credentials that anybody can copy and use and then pretend to be the user. And also IDPs became honeypots because they were holding all these usernames and passwords. And we had in September 18, a hack of Facebook in which 50 million user accounts were possibly compromised. But not only were the Facebook accounts compromised, because Facebook was using IDP for login, then the accounts that the user was using to log in were possibly compromised as well. So the model gives too much power to the central IDP. And this is obviously why Google and Facebook like being identity providers for federated identity management, because as this diagram shows, they are the center of the universe. Everybody must go via the IDP. Then CardSpace came out. This was invented by Kim Cameron as a result of the failure of the passport system, which was another federated identity system. But in that system, you had to trust Microsoft as the identity provider. And obviously not everybody trusted Microsoft. So Kim developed his laws of identity and he designed CardSpace to abide by his laws of identity. And in this, you have an identity provider, which all models have, which gives managed cards, but they also introduced the concept of self-issued cards, where a user could create their own cards and store them on their desktop. And this is a picture of the CardSpace when it was around, where there were cards that had been issued to them, and then there was other cards. You could add your own cards to your desktop. What were the positive features of CardSpace? As I say, it supports self-issued cards as well as authority-issued cards. It separates the identity provider from the service provider by putting the user in the middle. So now the user becomes the center of attraction, not the identity provider. And the conceptual data flow is good. The service provider provides its policy to the user's identity selector. The identity selector sees if it can match the policy. And if it can, it asks the identity provider to issue short-lived cards. And then the user submits the card to the service provider along with proof of possession. And it's a nice metaphor for plastic cards, and it's a nice GUI. And many of these features have been adopted today by verifiable credentials. When you see, when I talk a little bit about identity proof, you'll see a lot of the features of CardSpace have come through into verifiable credentials. What are the limitations of CardSpace? Well, it's potentially a nice user experience and metaphor, but user trials found it was too difficult to use. and only a single card could be sent. So the user couldn't merge different cards, and often in transactions you need several cards. So that was a major failing. And in auditing mode, the identity provider learned which service provider you were talking to, so the privacy protection was broken there. And the user had to be involved to select a card, so it couldn't be used for delegation between services. And it also only had a limited number of authentication mechanisms. So in the end, Microsoft discontinued it in 2011. Then OpenID Connect came along in 2014 to today, which is an improvement over SAML because it works in essentially the same way, but it uses JSON instead of XML. And JSON is a lot easier for developers to work with. It also supports mobile phone apps. And it's got some interesting concepts of supporting aggregated claims, which is one of the failings of CardSpace. You can aggregate claims from an identity provider, and the service provider will send aggregated claims to the service provider. Or it supports distributed claims, where the identity provider sends the service provider a set of endpoints and says, look, you can pick up more claims about this user from these different places. So those are two nice features that got added into OpenID Connect. And also it's got the concept of a self-issuing identity provider. What is a self-issuing identity provider? It's, I am the identity provider. I will issue my own identity tokens. So here's a pictorial representation of a self-issuing open identity provider. The user goes to a Reliant party to log in and access its services. It gets redirected to the OpenID provider, which is now a self-issuing provider running in your own device. So you log into your own device, you say, I consent to the release of my attributes that I've created, and you send your own self-issued attributes to the Reliant party, and then that will give you access. Now, in reality, that's not very good, is it? Because if users are saying who they are and what they are, then who can believe that? But it's being developed now, as we speak, within the OpenID Federation to carry verifiable credentials from a user's wallet to RPs. And so that is the protocol that I think will become the dominating protocol for verifiable credentials, which we'll look at later. So verifiable credentials then. They are the electronic equivalent of today's plastic cards, passports, and other physical certificates. And they contain cryptographically protected identity attributes. And they can obviously be used for authorization in attribute-based access control systems. So if we look at federated identity management assertions and we look at plastic cards, passports, and verifiable credentials, what's the differences? Well, users only show their credentials to SPs that the IDP trusts, which we said that was a major failing in SAML, that they were not, in Shibboleth, they were not releasing the attributes that were wanted. But with if you've got access to them and you're holding them yourself, you can show any card you want to anybody without actually contacting the IDP and not having their permission. The IDP knows which service provider the user is visiting and controls this, so it becomes this collector of information and knowing all about you. Well, with plastic cards, the issue does not necessarily be aware of who you're showing your cards to. Normally, the IDP has to provide all the credentials, but with passports and plastic cards, you can aggregate many cards together. Credentials are short-lived, so not revocable. Cards can be long-lived, but then the user has to phone up the issue and say, I want to revoke the cards. But essentially, the user are in control and not susceptible to phishing attacks because you don't have the redirections. So there are many advantages from using verifiable credentials. This is the verifiable credentials architectural model. You can see the holder, which is the user, is in the center. They are the center of the ecosystem. They get credentials from issuers. They collect credentials from multiple issuers. They collect them together into what's called a verifiable presentation, and they send the verifiable presentation to the verifier. Now, at the bottom of the picture, we've got what's called a verifiable data registry. This is a common data store. It could be a web page. It could be configuration files that you send to people. It could be a blockchain. It's somewhere where common understanding of information is held so that people have access to them. It's the metadata store that has to exist so that everybody has a common understanding of the schemas and the keys, etc. So VCs allow organizations to comply with GDPR very easily. Both the issuer and the verifier can comply with GDPR because the data subject can give consent to both the issuer and the verifier in the release of the credentials. They can demonstrate consent by signing the verifiable presentation. They can prove that it's necessary for the performance of the contract by showing that this is what we want. They can, by having data minimization, they can publish their policies to say this is what we want, and we're showing that it's necessary for the performance of the contract. And indeed, in our system, we have a public repository of policies which allows the verifier to show that these are the attributes that I need for the particular transaction. They're always accurate and up to date because they're digitally signed, so they're secure as well. And you don't require identification of data subject. The data subject only needs to put in the attributes that are required by the verifier. And if the verifier only needs your date of birth, they don't need anything else about you, then that's what you'll get. So standardization of verifiable credentials. This was done in 2019, and unfortunately, protocols were out of scope of the standard. So that means that whilst we have a standard for verifiable credentials, we don't have a standard for an ecosystem because there is no protocol for carrying them around at the moment. We're working on it, and there are several different competing protocols being worked on, and we'll look at that in a minute. But it does mean that verifiable credentials are way behind other federated identity management products in terms of standardization. The other thing they didn't do is they didn't standardize on one crypto. They allowed many different types of crypto. So again, that leads to islands of non-interoperability. Then they started work in 2019 on things called decentralized identifiers, which I'll look at in a minute. And decentralized identifiers was published in 2021, but progress has been halted because there's some very large IT organizations don't agree with that standard. So at the moment, that is not progressing. The credential community group within W3C is progressing on other certain VC issues, and they're working on other documents which will eventually hopefully become future standards. So that's looking at what a simple verifiable credential looks like. It's got this initial property called an app context, which we'll look at next. And then it's got the ID of the user, the type of credential, who the issuer is, what date it was issued, when it expires, and then the attributes of the credential subject, including an optional ID of the subject. Now, this context attribute is there to map globally unique URIs into user-friendly aliases. One of the problems we found with X500 and LDAP was that X500 defined globally unique attribute types in terms of object identifiers. Example 2.5.4.3.1 is globally unique, but LDAP used local friendly strings like telno. Telno in one directory was the same as telephone number in a different directory because they were local strings. And what context does is it maps globally unique URIs into user-friendly strings. So the verifiable credential will contain user-friendly strings, but the context tells you it's this globally unique attribute. So there can never be confusion over the strings and what they mean. Now, looking at decentralized identifiers, this provides a level of indirection between a public key and an identifier. The idea was that everybody would have a DID, which would point to a DID document stored on a blockchain, and on the blockchain would be your public key. That was the original idea. Everyone would have a DID. And we even had some countries and organizations that were planning to publish their entire population's DID on the blockchain. Bad idea. Why is it a bad idea? Because DIDs are globally unique correlating handles. So they're just back to the X509 distinguished name model. Okay, we don't want to be publishing these so that everybody knows everybody's globally unique handles. So they should not be stored on blockchain. Only those potentially of issuers and verifiers may be stored on a blockchain if you want. But blockchains also notoriously resource hungry. They use a lot of energy. They're not an efficient way of storing things. And then they actually changed the model so that DIDs no longer need to have an associated DID document at all. Finally, users are notorious at losing their secrets. And if they lose their private key that links to their DID, then they're in a pickle because they've lost their identity and lost access to their identity. And I don't know if you're aware, but one of the problems with Bitcoin is they reckon that possibly 20% of Bitcoins have irretrievably been lost because users have lost access to their keys. So what's the point of DIDs? We can simply use public keys, and we should use transient public keys rather than persistent ones because users will lose them. So I'd say the standardization problem with W3C VCs is it only standardized the data model. Didn't standardize a schema, which is in the X500 model, didn't standardize protocols or cryptography or a trust model or a query language. So there's a lot of work to be done in the standardization area for verifiable credentials. Here is my proposed solution. Schema applications will standardize them with LUK. Each application will standardize its own schema, although there are some central schemas in schema.org which everybody can use, like name, address, person, things like that. Protocol I'm hoping that OpenID Connect, with its 2 extensions for self-issued OpenID Provider v2 and OpenID Connect for verifiable presentations, which are currently in development, will become the protocol of choice, because it will allow organizations that are using OpenID Connect today to migrate towards verifiable credentials without a lot of pain. Cryptography, JSON Web Signatures and JSON Web Tokens, because everybody's using those today. And the trust model, Fraunhofer's Train, because this uses the DNS and EXI trust lists, and EXI trust lists are in use throughout the European community for getting trust in trusted third parties. And there's a presentation exchange language being defined in the Decentralized Identity Forum for the policy query language. So these are topics we can have in a second masterclass if we want to dive down to these in more detail. There's not time today for that. So implementing a VC ecosystem, as I say, most people have adopted long-lived DID blockchain-based approaches, but it's a number of serious problems. DIDs are privacy invasive, they're impossible for users to lose. You know, a 24-character random string of numbers is just hopeless. They're long-lived, which requires privacy protection revocation system, which is notoriously difficult. And selective disclosure is complex because then you need a zero knowledge proof algorithm to actually do selective disclosure. So we define an alternative based on W3 Web Authentication FIDO2. Short-lived VCs on demand, like OpenID Connect, like SAML, using conventional cryptography. And our free pre-standards release is described here in IEEE Communication Standards magazine from December 2019. So what is FIDO? FIDO, if I'm sure some of you have heard about it, fast identity online. It allows people to authenticate with an asymmetric key pair that they create on their device. And the key is stored in the device. It never leaves the device. It's in the device's hardware. And it uses the same origin policy, which means that this key can only ever be used with that origin. It can never go anywhere else to protect the user's privacy. But FIDO only provides strong authentication. It doesn't identify the user and it doesn't authorize the user, which are the main goals of verifiable credentials. So it seems natural to take 2 W3C standards of authentication and verifiable credentials, merge them together, and you've got a live operating VC ecosystem. So in our identity proof product, VCs are short-lived, issued on demand to fit the RP's requirements, selective disclosure, okay? In registration, when the user registers, they register their wallet with the VC issuers using FIDO2, so they get a strong key pair set up with their issuer. They can go back to the issuer whenever they want by simply swiping their finger on the device, and they'll get an asymmetrically authenticated connection. And the issuer gives their wallet a copy of the verifiable credential. He said, these are the attributes that we can release to you when you want them. And the user consents to these being released. So he's now got a copy in his wallet of credentials, but they're not digitally signed. They're not verifiable credentials. They're just credentials telling the user, this is what you can get when you need them. Now, when it's time to use them, the user's application contacts the service provider. The service provider sends its policy to the wallet. You can see how this is modeling on the Microsoft's CardSpace system. It sends the policy to the wallet. The wallet compares the policy with its attributes, with its credentials it's got. It also allows for selective disclosure because the service provider says, I only need these attributes, I only need your date of birth and your name, nothing else. Okay, the wallet checks it, and assuming the match, it requests the issuers to issue short-lived credentials containing just the identity information that is needed. It then combines these together in the verifiable presentation. It signs the verifiable presentation to prove possession and sends it to the service provider. What's the benefits of CCP's mode of operation? Instant revocation. As soon as the issuer removes the user's data from its database, then no verifiable credentials can be issued anymore. There's no cumbersome and privacy leaking revocation list needed. Instant update. As soon as the issuer updates its database, then all the VCs will be issued from updated data. You can never have stale information issued in VCs. Strong security with FIDO2 and keys in hardware. No usernames and passwords. Users' biometrics unlock the FIDO keys in the hardware. Fast and efficient. Uses conventional cryptography, not ZKP, so no slow job blockchains either. And a low total cost of ownership. Now, in terms of videos, these videos are available for you. I think we're probably running a bit short of time, so I won't show the videos now, but you've got the URLs and we'll make sure they're publicly available to you, okay? We'll finally look at the business benefits of verifiable credentials compared to physical documents. Physical documents are slow, as you know, difficult to validate. You know, you have to ring up or check with people. They're easy to copy and forge, expensive to produce, and difficult to remove from a holder. Whereas verifiable credentials are very fast to validate, milliseconds, highly secure. You can't reproduce the cryptography, and a good design allows for instant revocation update and low cost to produce. And what are the benefits compared to federated identity management? Well, federated identity management usually requires users to have passwords, and password management is expensive and time consuming, may require two-factor authentication, which is cumbersome for users, and it allows your users to be phished. Verifiable credentials don't allow phishing, they remove the need for usernames and passwords, they allow automation of processes that can't be done today, and they reduce your costs. And users like them. From the user trials we've done, they actually like using them, they're very easy to use. So, conclusions. Identity management is extremely complex. It's been evolving over decades. We're still not there with a final ubiquitous system that everybody uses, still considerable state of flux. Many different initiatives have been proposed over the decades, all lacking some capability or other. Perhaps in 10 years' time, what we're using will be somewhat different to what we've got today. But I'm sure VCs will have some part in that. But this is an analogy. In the 1980s, when I used to leave my car in a rough area when I was a student at university, I used to have to take the keys with me, put a steering wheel lock on, and even remove the rotor arm for the car to stop someone starting it. And now in 2000, I just simply press a button, it immobilizes my car, locks all the windows, locks all the doors automatically. Higher security, much more ease of use. That's where we want to get to with identity management. Okay, I'll hand over to Sean now, just to say about booking a meeting or a demo. Sean.
Hi everyone. Thanks, David. It was a flyby of a long history of identity management and a lot of knowledge to convey in a short period. But thank you for that. Just wanted to say to everyone, obviously, we haven't had a chance to show verifiable credentials working in practice, but we can provide you with a demo and an overview of that. And there's a link which I know that Sophie's already shared in the chat. So if you want to sign up as a call to action to come and meet us, we can walk you through that, give you a 30-minute meeting just to show the platform, particularly if you think it would be applicable, or this kind of technology would be applicable to any of your clients or to your own business itself. So please do take us up on that offer at the link. And at this stage, I'm going to hand back over to Kevin. I think he's going to moderate some questions, and hopefully there's been a few of those. Yeah. Over to you, Kevin.
Great, thank you, David. Thank you, Sean. We're going to go back to the beginning, David. Just what are your views on the trust broker model? Do you think it is a fudge to essentially ensure the lack of trust in a CA?
Well, it's not really a fudge. What it's trying to do is balance the system, because the system is balanced against the user at the moment. Users really don't know anything about CAs. They don't know how to evaluate their certification practice statements, their policies. They're really close. They have to rely on someone to do it for them, and that's usually the computer manufacturer or the browser manufacturer that builds that into their system. They've got no idea which of these 400 CAs in the world are being trusted. What the trust broker does, it says you as a user can have a contract with a trust broker. Okay, you may pay him a small amount of money each year, like an insurance policy. All your certificates will be sent to him before you make that secure connection. He will validate them for you. He will check their certification practice statements, make sure they're suitable for the transaction in hand, tell you you're okay to go ahead. And if you suffer any loss, he will compensate you for that. Okay, so that's the model. And as I say, that's now been adopted by the eIDAS scheme. So I don't think it's a fudge at all. I think it's trying to balance up the weight of the user and give the user more power and control.
Yeah. Slightly controversial question next. What is the difference between card space and verifiable credentials?
Oh, lots of differences. Card space didn't really allow selective disclosure. Card space controlled how the authentication went between the user and the identity provider. Card space didn't allow amalgamation of multiple cards. So that's just some to begin with. So basically, verifiable credentials is put in a wallet, and also card space didn't work on mobile phones, mobile devices, etc. So it's
it was quite tied to Windows, if I remember rightly. So
exactly.
It wasn't very portable.
Yeah, but there was a lot. I mean, millions were invested. Millions, not only by Microsoft, by lots of implementers as well, because they really thought it was going to take. And I thought, well, I mean, we did research at the university, and we built a card space in the cloud which took it from Windows and put it in the cloud, and we got papers published on that. But then the whole thing just ceased. So,
yeah. Sorry, we've got a question over in the Q&A. If you do have questions, you can put them in the Q&A box. That would be helpful. But we've got another one. How would this all work in countries where personal hardware devices, phones, etc., are not as ubiquitous?
Good question. We've actually got a paper-based system. And in fact, the second demo of the two demos, which is on YouTube, shows using a paper-based credential. So basically the way it works, we did this for the NHS when we built COVID certificates for them to show. On one side of the paper, you have your credential printed with all the details. And on the other side, you have a QR code. And so if the other person doesn't have any electronics, they'll just read your paper credential. If the other side has electronics, a scanner or something, they can scan the QR code. That goes off into the verifiable credential system, retrieves what they want, because they can ask for selected disclosure as well, retrieve what they want, get it back, digitally signed as a credential, and then they can actually validate that this is genuine information. So there's a demo of that on YouTube now, which you can look at.
It was, I think, I want to make sure I try and get this right, but it says, is the application to national DIDs and authentication platforms? Or is this an application to national DIDs and authentication platforms?
Absolutely it is. If you look at the government's latest work on identity and attribute framework, then there are only two standards that they've recommended in there. Guess what they are? W3C verifiable credentials and OpenID Connect. They're the only two standards that are actually mentioned in that document.
We'll come to the next one. What are your thoughts or ideas on authentication of things such as IoT devices?
That's very interesting, actually, because when we started this work at the university several years ago, we actually worked with an IoT company. So we built our system to work with IoT devices as well. So the verifiable credential doesn't have to be attached to a person. It can be attached to a digital twin. So those are device and operate just like a person with verifiable credential. We built our system to actually do automatic policy vetting and check-in, so that it will check the wallet against the policy and it'll do automatic selection. Rather than asking the user, it'll just say, okay, then we know we match, it doesn't really matter which one we send. And so there's no human interaction needed for it to work.
Right. Regarding authorization, do you see a future in attribute-based access control models?
Yeah, I do. I mean, Hexaconal, which was developed, nearly probably getting on for 20 years ago, been very successful, actually, and companies have made a lot of money after that. And we've done some work in the area. It took over from RBAC, I think, because RBAC was also very popular, but limited, and ABAC just extends it by adding more attributes. So verifiable credentials, what verifiable credentials do, allow you to present to an ABAC system, these are definite validated attributes of the subject. Then you can continue in your existing, ABAC system, or however you do your identity management on attributes. You just know you're getting a verified set of attributes about the user.
Yeah. In the event of a loss, how easy is it for the user to attain new credentials?
Okay, so that depends on the particular VC system you've bought as to what they do for backups. Some of the VC systems that are using software-based keys will allow the whole wallet and the keys to be backed up to the cloud. Okay, now obviously, once you allow that, there's a danger there that if you can back up the cloud, and an attacker can steal your whole thing and become you as well. Our system, which is based on keys in the hardware, does not allow backup to the cloud, but the user can register multiple devices, and we allow the copying of credentials from one device to another. We're using different hardware keys on the device. So so if you bought a new phone, you could migrate everything from your old phone to your new phone. If you lose your phone and it's your only copy, then you'd have to start again from scratch. But I think if you lose your phone, losing your verifiable credentials is probably the least of your worries, because you've lost credit cards and all sorts of stuff. And yeah.
I'm just going to swap the questions around a bit. Will there be more stringent mechanisms to prevent poor implementations of these new technologies?
Good question. Well, the government's identity and attribute assurance framework, that's trying to build in assurance. It's trying to build in regulation to get people to go through certification bodies as such. So whether it'll in the end be self-certification, here's a set of rules, certify yourself and get it, or whether they have external auditors or not, we'll have to see how it works in practice. But I think, yeah, there will be some mechanism. And there is some of the people working on what's called trust marks, whereby you get audited and you get certified, and then you can put a logo on your site to say, I mean, FIDO does this, doesn't it? With FIDO, you get certified as being FIDO compliant, then you can put the FIDO logo there. And of course, if you're not FIDO compliant and you use the FIDO logo, you can be done for breaking copyright rules. So that's, so there are, I think that's what will happen eventually. Yes, I'm sure.
Do you see that sort of industry self-regulation coming in to verifiable credentials?
I could see that. But I think for some more high value transaction, I think there would be more government certification for that.
Yeah. So I'm just going to come on to something slightly different. Related to the online safety bill, the news that age verification could be a legal requirement for people to access 18+ content. There are clearly many potential problems with an age verification system. This includes privacy concerns and what technical processes could be used. Is there a technology today or on the horizon suited to age verification that could maintain a user's privacy?
Yeah, absolutely. Absolutely. We've already demonstrated it with verifiable credentials. So you can actually go to a relying party. The relying party can say, I just need the government to assert that you're over 18. And then you get a verifiable credential from the government and it just says you're over 18. And that's privacy protecting, and it's issued by the government. As long as the relying party trusts the government, then it will be able to verify it. The problem with the current proposed legislation, of course, with adult sites, which is in the news today, is that it's not ubiquitous. It's only for people from the UK. And until it becomes global and a global requirement, then people just dodge it, because they'll say, I'm not from the UK. They'll use a VPN. They'll go to the website, say I'm from Germany, and then they won't have to do any checking. And the websites can say, well, it was in Germany. I didn't need to do anything. So, I mean, that is the problem with the government scheme at the moment, I think, is the VPN hole. I'm not sure how they plan to address that. I don't know if it is addressable, actually.
Do you think that this is a place where verifiable credentials could come into play?
Oh, absolutely. Yeah, definitely. For sure.
Can you see a time when every citizen hosts their own attribute store in a way that doesn't introduce the risk of loss of physical device, loss of a physical device that provides access to everything that the person has? People that struggle with technology may struggle to host their attribute store, for example.
Yeah, well, I mean, you can regard the wallet on your smartphone as an attribute store. Okay, it is that, actually. I mean, it's basically a wallet with verifiable credentials from a whole bunch of issuers, and they've all got different attributes. So you can have one from DVLA with your driving license, one from Passport Authority with your passport, one from your university with your degree certificate, etc., etc. So it is an attribute store. Okay. If you're not familiar with using mobile phones and you're not familiar with computers, then you need to have it paper-based, don't you? I think that is that's the ultimate fallback for anybody, is give them their credentials on paper or on plastic cards like they do today, and they carry them around. If they've got a certain amount of computer literacy, they don't have the latest smartphone, but maybe they've got an old smartphone or a PC or something. Some people are looking at storing this in the cloud and giving them access to the cloud. But then you have to make sure that they're not going to lose their credentials for logging into the cloud. Those credentials have got to be strong enough to stop hackers logging into the cloud pretending to be them. So that produces its own set of problems if you're not going to put it on the user's device. Because if it's on the user's device, you've got two-factor authentication immediately, because you've got to have possession of the device and you've got to have the PIN or the, something to unlock the device. If you put it in the cloud, you're going to have to introduce, some strong authentication, which will work.
Yeah.
Yeah.
Next question. We've got some good questions coming. Could your internet connection have a verifiable credential that can be used to prove you're coming from the UK?
There's no reason that anything can't have a verifiable credential, actually. So your ISP can give you one. So if you actually, that might be a way around the VPN issue, is that if the relying party says, not only do I want a verifiable credential that you're over 18, I also want a verifiable credential from your ISP now, okay, where you're logged into now, then we could do that. So actually, that's whoever raised that question, 10 out of 10, that is a potential solution to the VPN problem, actually, if you request a verifiable credential from your ISP. Yeah, I like that. I like that.
This just follows on from that. Regarding receiving assertion from the government, doesn't that still violate user privacy and letting government know you are viewing some website?
Yeah, well, if you go for the short-lived version that we've got, they know you're active. They know you're doing something because you've asked for a credential to present to something. So they don't know where you're going or what you're doing. Okay, so you're protecting their privacy in that respect. If you're using a long-lived one, then you don't need to go to the issuer to get it, but you present it to the website, but the recipient then has to do a revocation checking. So if that revocation checking involves going back to the issuer to say, has this credential that's a year old, has it been revoked? Then that's leaking it as well. So, you've got swings and roundabouts there you need to balance up.
Question. So most of these standards that you talked about in history sort of got to second or third version before they got to sort of widespread adoption. Where are we with verifiable credentials? Are we good to go with the first version, or do you think there's more versions to come before it gets adopted widely?
We're actually we've just got a proposal being produced for W3C for version 2, okay, of the data model. So there will be a version 2, but as in FIDO became operable at FIDO 1, it became FIDO 2 at the W3C, okay, and they've now got a second version of FIDO 2 as an updated standard. So, standards are involved, but it doesn't stop you using them, and hopefully the software providers will migrate their products to the latest developments as they come along. The big problem with verifiable credentials is not the data model, because the data model is pretty solid. The problem is no protocols, no minimum crypto. Yeah, so we've got different competing cryptos. That's the big interworking problem.
I guess that was the one thing that stood out for me, was you need to get to that same status where you've got a checkbox check against everything that you're looking at, and without a consistent approach, people are going to take different models and implement in different ways.
Yeah, exactly.
Right. And just say to everyone, if there's any more questions, now is your time to drop them in. I think let me just check. We've gone through most of them so far. So I think in terms of verifiable credentials, it's at demo stage. We've got past that. We're sort of starting to see some real applications. Where do you see the next steps in the next couple of years?
Well, I think there has to be some sort of harmonization. I cannot believe that there are over 100 DIDs registered now, which is just completely madness. I can't believe that every verifiable credential system on the planet is going to support 100 DID methods. So there's going to be some shakeout. In fact, our system doesn't use DIDs at all. It uses URLs because everybody knows what URL is and they can use them. So there's going to be some shakeout. There's got to be some harmonization against things. And I think that harmonization won't come until people gain practical experience, when they determine that actually blockchain wasn't really a good idea. A lot of people have thought blockchain's not a good idea, but not everybody, and they're still using it. There's the things like that are going to have to be ironed out. And also price will determine something. You know, with the VHS and the Betamax, it wasn't necessarily the best technology, it was the cheapest one that won, and VHS took some. So there might be something like that that takes the day. And then, of course, coming down the line, we've got MDL. We haven't talked about MDL, but MDL is the mobile driving license standard from ISO. And that's starting to be rolled out in America, and Apple have given support to that and said they're going to put it in their Apple Wallet, but they're not verifiable credentials. However, version 2 of the ISO standard of MDL will have verifiable credentials in it because it's already in a draft appendix of the working document. So there's going to be a verifiable credential data model for driving licenses, which is really good news, because at the moment the MDL data model is totally fixed for MDL, nothing else.
And is that going to be the same as the verifiable credential standards that you're working with?
Yes, it will be, but it'll probably be a different crypto, because the crypto is not standardized. So it'll probably be a different crypto. So there's going to have to be there's either going to have to be, you know, systems supporting multiple crypto, not only crypto language, crypto algorithms, but different crypto mechanisms. Like LD proofs are very different to JWTs. So either Reliant parties are going to have to support multiple cryptos, or there's going to have to be some focusing down, say, the market decides everybody's using this crypto, and then you have to implement it. I don't know. We can't tell the future, can we? We don't know exactly what's going to happen.
And we're coming up towards the end of the session, but we've got a really good question here. Can you suggest an RFC or other documentation we can use to read up on this for more information?
Okay. Well, no, there is no RFC. There is a book, and I've written a chapter in the book, but I'm not happy with the book because the book tells porkies. It's a book on self-sovereign identity, and it's totally focused on DID and blockchain. So even though I wrote the chapter on verifiable credentials, I didn't know what the other chapters are going to be by all the other authors. But I'm happy to release. I mean, I've been commissioned to write a book on verifiable credentials, but I've not got time to do it at the moment. So no, I cannot recommend a good source for independent stuff on verifiable, except the chapter I've written in verifiable credential book. But I don't think that's publicly available as a chapter on its own without buying it, unfortunately.
Sounds like that's an interesting gap in the market at the moment, because it's like we need that reference information somewhere. I've had a contract for a year now. I was supposed to publish the book in December of last year, but with a takeover and one thing or another, I never got around to writing it. So, and just a comment at the end here. Glad to hear you think blockchain is a solution without a problem.
Well, yeah. In fact, basically, I use, you know, if you've got a hammer, everything's a nail, right? Well, DIDs and blockchain are the hammer, and so everything becomes a DID. You know, everything requires a DID and blockchain. Do you know they've got DIDs for accessing the DNS, and they've got DIDs for accessing web pages? I mean, it's completely gone mad. It's like we've got a hammer, so everything's a DID, and so they've created standards for DID web and DID DNS. I mean, you know, it's crazy.
I think we're at the end of the question, so I'd like to say, David, thank you very much. That was incredible, rapid walk through the history of identity. I'd say that I can remember almost every one of those, which is frightening, but very enjoyable to see where we've come from and where we're going to. And Sean, is there any final comment from yourself?
No further comment from me, Kevin, but like I said, if anybody wants to meet up with David and I to talk a bit more and have a look at things, then please do submit on the link that we shared.
And comment just coming. Thanks for subtly altering my views. So I think I take that as a very successful masterclass. So thank you both very much. Thank you, David. Thanks. And learned a lot from that.
Thanks. As I say, there is scope for a second one later if we want to, deep dive at maybe 6 months' time or something. Yeah. Okay. Thanks very much.
Thanks, everyone.
Thank you, everyone, for attending, and hope you enjoyed the session, and look forward to seeing you at the next masterclass.
Thanks, everyone. Bye.